Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. I think you should have completed at least the first two answers, the answers to the first two questions.
Yes, ma'am.
Yeah. So, what is the radius of the hemisphere? In the first one, what is the radius of the hemisphere?
10.5.
10.5, ma'am.
10.5 centimeters. All right. And the curved surface area?
693 centimeter square, ma'am.
693. Very good. Yeah. All right. Let's those who've understood the first one clearly can continue working. You can take a screenshot of all the questions so that you can continue working. Yeah. If at all there's anyone who wants to understand the first answer, can listen to me. Yeah. So in the question, we are given the volume of the hemisphere. In the question, we are given the volume of the hemisphere. It's given to be 2,425.5 centimeter cubed. So this is given to us. What is the formula to find the volume of a hemisphere? 2 by 3 pi r cubed. This is the formula to find the volume of a hemisphere. So 2 by 3 pi r cubed is equal to, when you convert this to an improper fraction, this is what you get, 4,851 by 2. So 2 by 3 pi r cubed. Why 2 by 3 pi r cubed? Because this is volume. Volume of the hemisphere is equal to, when you convert this to a mixed, when you convert this mixed fraction to an improper fraction, this is what you get. So you can see this equation. There's only one unknown r, because pi, the value of pi is 22 by 7. If nothing is mentioned, pi is 22 by 7. So if you look at this equation, there is only one unknown r. So you can solve this, meaning you can work this equation and find the value of r. So how do you work? 2 by 3 into 22 by 7 into r cubed is equal to this fraction, 4851 by 2. So r cubed will be equal to 4851 by 2. This becomes 3 by 2 when transposed, and this becomes 7 by 22 when transposed. Now simplify. Now cancel. Okay, so upon cancelling, we get 441 into 3 into 7 in the numerator, and we have 3 2's in the denominator. We have 3 2's in the denominator. See here, 3 2's in the denominator, and in the numerator, we have 1 3, 1 7, and 441. So don't multiply. Don't multiply you, because r cubed is this value. You need to find the value of r. So we'll express the RHS also as a perfect cube. The LHS is a perfect cube, r cubed. So we'll express the RHS also as a perfect cube. So how can we do that? Take up this number 441 and find its prime factors. So you can write 441 as 3 into 3 into 7 into 7. 441 is equal to 3 into 3 into 7 into 7. Do not multiply. The left hand side is r cubed, which is a perfect cube. So we'll express the right hand side also as a perfect cube. How can we achieve that? Find the prime factors of 441. 3 into 3 into 7 into 7. So you can see here 3 into 3 into 7 into 7 for 441. And then this 3 and 7 as it is, 3 and 7 as it is, divided by 2 into 2 into 2. So now what happens? How many threes we have? 1, 2, 3. 3 threes. And 1, 2, 3. 3 sevens. So we have 3 cubed into 7 cubed by 2 cubed in the RHS. So you can write it as 3 into 7 by 2 the whole cubed also. You can write it like this also. It's nothing but 3 into 7 by 2 the whole cubed. So we have expressed the RHS also as a perfect cube. LHS is r cubed, perfect cube. So we have expressed the RHS also as a perfect cube. 3 into 7 by 2 the whole cubed. So now so r cubed is equal to 3 into 7 by 2 the whole cube. So r will be equal to 3 into 7 by 2, which is 21 by 2 or 10.5. So we found the radius. Now the question is to find the CSA of the hemisphere. See, that question is actually to find the CSA of the hemisphere, which is not possible without having the value of r. The formula to find the CSA of a hemisphere is 2 pi r square, wherein you need the value of r, which is not given to us in the question. In order to find the value of r, we are given this information. See, either the value of r is given to you straight away. Take r is equal to whatever. If it is not given, then some other information will be given with the help of which you should find r. The question is only to find the CSA of the hemisphere, which is 2 pi r square. So 2 into 22 by 7 into r. We don't have the value of r. So that means before you work this, you have to find the value of r. It's not given. Then some other information will be given to you in the question to find the value of r. And that information is the volume of the hemisphere. Why is this given? When you read the question, it may sound irrelevant. Why is the volume given? They want the CSA. Why is the volume given? The volume is given because they have not given you the radius. They have not given you the radius of the hemisphere. So they've given you another information like this, using which you should find the radius of the hemisphere. And that's exactly what we did. We made use of this information to find the radius of the hemisphere. And now in the formula 2 pi r square, which is a CSA of the hemisphere, take the value of r and find the CSA of the hemisphere. Yeah, I can wait for 3 minutes. Quickly take down the answer. Those who have not got it, don't take a screenshot. Please work it. I'll give you 3 minutes. One more minute. All right. What's the answer for the second one? What's the time needed to empty the tank?
55 minutes, ma'am.
55 minutes, ma'am.
55 minutes. All right. Any other answer? Yes. Ananya, what's your answer?
I'm working.
Okay, Deepika. Hitesh. Hitesh. Nandini said
Ma'am.
55. Yeah.
55 minutes.
Hitesh, what did you say?
I'm doing it.
Okay. Nandini said 55. Priyanka?
I'm working.
All right. Raja Rajeshwari?
55 minutes I got.
All right. Ram said 55, right?
Yes, ma'am.
Okay. Sashmin? I'm not blessed to hear Sashmin's voice. Okay. I'm working on it, ma'am. All right, Sashmin. Thanks for the response. All right, Sashmin. Shreyas said 55. Tarun?
I'm working, ma'am.
Working on it. Okay, but we have to now see the answer. But before that, again, those who want to listen can listen. So a cylindrical tank full of water is emptied by a pipe at the rate of 225 liters per minute. So that means the emptying pipe can remove 225 liters of water in 1 minute. So if you keep the emptying pipe open for a minute, if you keep the emptying pipe, so the emptying pipe will be located at the base of the tank. The pipe which is used to fill the tank will be on top of the tank. The pipe through which water is filled will be somewhere on the top of the tank, and the emptying pipe will be at the base, the floor of the tank. Now, it's mostly kept closed. The emptying pipe is kept, meaning the emptying outlet, that's closed. Only then the water can stay inside the tank. Okay, now when you let it open, okay, when you let the emptying outlet or pipe, whatever you call it, open for 1 minute, then 225 liters of water is discharged from the tank. Please understand that. Cylindrical tank. So somewhere here is the emptying pipe. Okay. Normally it's closed. When you need to store water in the tank, when you need to store water in the cylindrical tank, this one is closed. When you let this one open and allow the water to flow out, if you let this outlet open for 1 minute, then 225 liters of water from the tank will flow out. If you let it open for 2 minutes, then 450 liters of water will flow out. Now, what is the question? So this is the speed of water. This is the speed of the water. 225 liters of water will flow out in 1 minute. This is the speed or the rate at which the water flows out of the emptying pipe. How much time will it take to empty half the tank? So you don't want to empty the full tank. How much time will it take to empty half the tank? If the diameter of its base is 3 meters, that is the radius of the tank is given to you. Diameter is given, so radius, and its height is 3.5 meters. Of course, to answer any question related to a cylindrical container, you need to know its radius and height. To answer any question related to a cylindrical container or a cylindrical tank, cylindrical drum, you need to know the radius and the height, and that's given to you. Very good. So looks easy. So with the radius and height, what can we do? We can find the volume of the water in the tank. That is the capacity of the tank, because it's full of water, no? So when you use the formula pi r square h, which is the formula to find the volume of the tank or the volume of the water in the tank, pi r square h, or the capacity of the tank, pi r square h. So you will get the volume or the capacity of the tank in meter cube, because radius is in meter, height is in meter, so you will get the volume in meter cube. But the speed of the water is given in liters. See, liter is also, I hope you're all listening, at least those of you who want to understand better. But the volume can also be expressed in liters. Liter and meter cube, both are units for expressing volume. Liter and meter cube, both are units for expressing volume. And we also know a relation that can convert volume in meter cube to liters and vice versa. If you have, you can toggle between these two. If you have computed volume in meter cube, there is a relationship with the help of which you can convert that to liters. If it is so many meter cube, then how many liters does it represent? You can convert using that conversion. Or if you have the volume in liters, you can convert it to meter cube. So don't worry about meter cube and liter. There is a relationship with which you can easily convert. Now you have got the volume of the tank in meter cube. and you understand why you have to convert the same volume to liters. So you have now converted. So you have used the formula pi r square h. You use the formula pi r square h, and you found the volume, the full capacity of the tank in meter cubed. And then you will divide that by 2. That answer you will divide by 2 because you'll have to find half the volume of the tank. So you will divide by 2 and you will get the, you will find half the volume of the tank in meter cube. Now you will use that relation and you will convert meter cube to liters. So supposing say 2,250 liters you get. Half the volume of the tank is 2,250 liters. For example, you find half the volume of the tank in meter cube, and then using that conversion, you convert it to liters. So that meter cube represents 2,250 liters, say. Now, 225 liters is emptied in 1 minute. Then 2,250 liters will be emptied in how many minutes? How many minutes?
Mom, I got 55.
Hare, is that the okay? Fine, but in my case,
Number of liters into 1 into by the time. Ma'am, 1 second.
class. So you're all expecting formula, not explanation and understanding.
Volume of the tank divided
see,
by.
my question. No, Ananya, it's not. My question is, see, what are you all doing, children? So I think I shouldn't be wasting so much of my energy, just give you some formula. Okay, use this formula, get the answer. Next, use this formula, get the answer. 225 liters is emptied in 1 minute. In my case, half the volume of the tank is 2,250 liters. How long will it take to empty that? So what's the point? You all answer this question. You got
2,250 liters divided by 25 liters.
Yeah, how much is that?
10 minutes.
10 minutes.
10 minutes.
What's the point getting 55 minutes as the answer when you cannot answer this simple question? So step 1, find the volume of the cylindrical tank. Step 2, divide by 2 to find half the volume of the tank. Step 3, convert the volume in meter cube to liters. Step 4, find the time. That's all. You have to check your answer. You don't have to use any formula. See this, it's like this. Volume of the cylindrical tank pi r square h, which you all know. You must have got 24.75 meter cubed. And half the volume of the tank, because only that has to be emptied. Divide half into, or you can divide by 2. Both are the same, divide by 2. So this is half the volume of the tank. Now we need to convert that to liters. Because the rate of emptying is given in liters, 225 liters per minute. So convert this meter cube to liters. What's the conversion? 1 meter cube is 1,000 liters. 1 meter cube is 1,000 liters. Now if you have a doubt, okay, if you have a doubt as to if you should multiply or divide, you can do this. See here, listen to this. All if you listen to this, we are here. Half the volume of the tank is 12.375 meter cubed. Or if you repeat, half the volume of the tank is 12.375 meter cubed. Repeat. Yeah. Unmute and say that half the volume of the tank is 12.375 meter cubed.
Half the volume of the tank is 12.375 meter cube.
Very good. Now it's in meter cubed, right? We need to convert that to liters. Now say 1 meter cubed is 1,000 liters.
1 meter cube, 2,000
liters.
1 meter cubed is 1,000 liters. Write it like this. See, 1 meter cubed is 1,000 liters. Then 12.375 meter cubed is how many liters? X liters. Cross multiply, that's all. This is, if you have a doubt or in the exam, you're nervous, you suddenly get confused as to if you have to multiply or divide, you can use this. You can just write it like this, or you can write like this. 1000 liters is 1 meter cubed. Then how many liters is 12.375 meter cubed? Meaning you should make sure that you have the same units in the numerator and in the denominator. You should not mix that. Either it is meter cubed in the numerator and liter in the denominator, or the other way. So how will you get the answer? Just cross multiply. Leave the units. Leave the units because they'll leave the units. X into 1 is x. X into 1, cross multiply, x into 1 is x, is equal to 1000 into this, which is 12375 liters. That's all. So if you don't know, if you have to, or that's what, this will help you to get it easily. Whether it's multiplication or division, just do this, you'll get the correct answer. Now you're almost there. So this is the capacity of the tank in liters. Now what have I written? Let this volume be emptied in x minutes. Let this volume be if you've used x here, say y minutes then. If supposing you've used x here and calculated, use y minutes here. Okay, so let this volume be emptied in x minutes. Again, see, there's an argument here, a proportion. 225 liters is emptied in 1 minute. Then so many liters will be emptied in how many minutes? That's all. It's a proportion. Product of extremes is equal to product of means. You don't have to write any formula, volume by time and whatever. It's just this. Or you can even write it as a proportion like this here. 225 liters is emptied in 1 minute. 12375 liters is emptied in how many minutes? X minutes. Cross multiply and you'll get the answer. There is no compulsion that you have to write the formula to get the answer. If you show your working clearly, your working should convey the convey the method or the idea you've used to the teacher. So if you show the steps, you get marks. There is no hard and fast rule that you have to use the formula. As I always say, there are so many CBSE schools in India, and you cannot expect every teacher to teach like your school teacher. Each one has their own way of, sharing knowledge with the children. So you should be convinced that you can work it in any way. So I think, according to me, this is the simplest. Just use a proportion like this. 225 liters is emptied in 1 minute. Then so many liters will be emptied in how many minutes? Numerator has liters, denominator has minutes. Or you can write it the other way also. 1 minute, 225 liters is discharged. Then in how many minutes, in x minutes, in how many minutes will 12375 liters be discharged? So you can use this for calculating time. You can also use this proportion, method to convert also. To convert 1 meter cubed is 1000 liters. You know that, but you don't know if you have to multiply or divide. Though you otherwise know it. Like when you're working at home, you know it. When you're cool-headed, you know it. And then in the exam, you're confused. So you can always use this. So half the volume of the tank will be emptied by the pipe in 55 minutes. So what you need to understand here is you need to read the question, understand the question clearly. Understand the question clearly. So here it was step 1, find the volume of the cylindrical tank, volume of cylindrical tank. That was step 1. Step 2 was to find half the volume of the tank, half the volume, to find half the volume. Step 3, to convert volume in meter, which was in meter cube, to volume in liters. Using the conversion, 1 meter cubed is equal to 1000 liters. Using this, we have found the volume in meter cubed here. So we need to convert that to liters using this relation. That is step 3. In step 4, we find the time. In step 4, we find the time. So that's what, it's very simple. Very, very simple. You just have to understand the question clearly. Yes, again, I can wait for 2 minutes. Quickly write down. From now, 2 minutes. Quickly write down. Yeah, third one, frustum of a cone, you do not have that. Fourth one, what's the internal diameter of each ring? Working on that, all of you?
Missed it. I missed it 4 centimeter.
How much?
4 centimeter.
Centimeter. Yeah, share your working, Shreyas. Oh,
Yes,
no, but
by chat.
no. My phone, it's not available at the moment. Okay, 4 is the right answer. Very good. So for word problems, children, this is what. Oh yeah, and one more thing is, it's not that I abruptly started volumes and surface areas. Frustum of the cone is the only part of volumes and surface areas which is new for 10th standard. The rest of it, the rest of the solids, were already introduced to you in standard 9. Only frustum. Frustum is the new part for 10th standard, which is not there for you. Fortunately or unfortunately, I don't know. It depends on you. It's not there. So, which means we could just start off like this. Yeah. Now, I'll tell you one thing. There cannot be anything easier than this chapter, volumes and surface areas. Reason being, for everything you have a formula. It's completely formula based. That's one. And the answer is in the question itself. Believe me, the answer is in the question itself. How is it in the question itself? I'll read it for you. See here. The radius of a, it's just about understanding the question and framing that first equation. If you frame that first equation, that is, if you start off correctly, you just need to construct one equation. If you construct that equation correctly, that's it. That equation will take you easily to the end of the answer. Easily you will go to the end of the answer. End of the correct answer. Now see here. All of you are working on the fourth one. Has anyone else got the answer? Has anyone else got the fourth answer, or all of you are working on it?
Working, ma'am.
Okay.
Working, ma'am.
All right.
Yes, ma'am.
All right. So now what is there? The radius of a solid iron sphere. Now visualize that. You shouldn't simply read the radius of a solid iron sphere is 8 centimeter, 8 rings of iron plate. You're not reading it for somebody. You're reading it for yourself, for you to understand. So as you read, you need to understand what you're reading. That should be the purpose. Simply reading the question and then scratching your head is of no use. The radius, so I'm trying to understand as I read, the radius of a solid iron sphere. So now I'm visualizing it, solid iron sphere. Solid, okay. Iron meaning the material. So leave that. It's a material. So that has nothing to do with the answer. It can be wood, it can be whatever metal. Okay, so iron has nothing to do with the answer. Solid, okay. Sphere, okay. The object, the solid is a sphere, fine. So immediately the formula, what's a volume? 4/3 pi r cubed, all right. And for that, what do you need? Radius, that's given 8 centimeters. So everything is there about the sphere. Solid sphere. Okay, you need the radius and that the radius is given to you. Fine. Now read ahead. 8 rings. Now you need to understand, the what kind of solid the rings are. 8 rings. Now, as you read ahead, from the values given, you should be able to understand or get the correct idea about the nature of the rings, what kind of solid they are. 8 rings. Now, when you read here, actually, you don't know 8 rings. Okay, 8 rings of iron plate. Iron again is the material. Iron, it can be wood also. So iron is just a material. Leave that iron. 8 rings of plate, iron plate, okay, of external radius. Okay, so you get when this word external radius is used, that means it's a hollow plate. It's a hollow plate. Okay, external radius and thickness. Yeah, so see here, when external radius and thickness is given, that means there is internal radius. Now, again, one more thing I have to tell you. Now, this thickness should be, okay, let me finish it and then tell you. Now, this thickness here is very deceiving. The thickness here is actually very deceiving. I'll tell you what. And the thickness is 3 centimeter. That means, see here, children, if you hold imagine you're holding a coin between your thumb and forefinger. Can you imagine that? Hold a coin. Okay, you hold your book, okay, between your thumb and forefinger. Your thumb and forefinger, like how you eat a sandwich. How will you hold a sandwich when you're eating it? Between your thumb and forefinger, right? If you're eating a sandwich, how will you hold the piece of bread? Between the thumb and forefinger. That is the thickness of the bread, which is the height here. That is the thickness, which is the height. The thickness here represents the height of the metal plate. Now you'll ask me, how do you know thickness is height? That's what I'm telling you. Thickness means you hold it between your thumb and forefinger. That means it's so thick. Your book, how will you check the thickness of your book? You'll use your finger, no? You'll use your thumb and forefinger and say, oh, so thick my book is. That thickness is given. That is the height. That's nothing but the height. The height of the ring is 3 centimeters and the outer radius, capital R, is 6/2/3. So for a hollow, so this one is a hollow cylinder because radius is given. Radius means something circular is there. External radius. So there is something circular. That's why radius is given. And height is given. And you have to find the internal radius. Clearly, it is a hollow cylinder. Clearly, each plate is a hollow cylinder because outer radius is given. The thickness is given. And the internal radius has to be found. So it's a hollow cylinder. So now what do you understand? Now I was talking about that one equation, right? Now I'll tell you that equation, see. I was telling you that one equation. If you write this, see here. Now you should understand that volume is always area of the cross section into height. Volume is area of cross section into height. All right. Now when it is a hollow cylinder, the cross section is a ring. Ring meaning this one. If you have identical rings like this, if you stack them, if you place them one over the other, you will get a hollow cylinder. Imagine you have paper cutouts of such pieces. You know, you have paper cutouts of such pieces. Okay, this is a ring. The shaded portion is a ring. Now this one is a plain figure. This one is a plain figure. It's made of paper. It's a plain figure. There's no thickness. It's hollow here. It's open here. Now you have many pieces like this. You stack them. You place them one over the other. Then it assumes some height. That one single piece has no height. The thickness is very negligible. That's why it's a plain figure. The thickness is almost zero. That's why it's a plain figure. A plain figure does not have thickness. It's two-dimensional, only 2 dimensions. So here, this circle, it looks like a circle, right? It's a plain figure. It does not have thickness. But if you arrange identical pieces like this to some height, then it's called a hollow cylinder. Then it is called a hollow cylinder because when you place identical pieces like this, when you stack it up, it assumes some height. Now you will get a height. And that one is a hollow cylinder, which has height, internal radius, and external radius. So a hollow cylinder, for a hollow cylinder, you need 3 values. What is the internal radius? What is the external radius? What is the height? So basically for a sphere, you just need the radius. But for a hollow cylinder, for a sphere, you need only radius. For a hollow cylinder, you need inner radius, outer radius, and height. Now this is given. This has to be found. This is given. Now what is the equation? Now this sphere is melted and converted into 8 rings. That means the material, all the iron in the material is iron, right? This iron is melted. The sphere is melted and it's converted into 8 identical rings. So it's just that it's taking a different shape now, but the volume of the iron will be the same in both the cases. The volume of the iron will be the same in both the cases. That is the volume of iron in the sphere. Because that is the sphere is melted and converted to 8 rings. So the volume of iron in the sphere, will be equal to the volume of iron. Iron is the material. It's a metal. It's melted and it's recast into 8 rings. So the volume of iron in the sphere is equal to the volume of iron in the 8 rings. This is the equation I said you should know to write. And this is so easy because it's given in the question. You don't have to, come to that conclusion. It's given to you in the question itself. 8 rings of iron plate of external radius and thickness are made by melting the sphere. So you know that the iron in the sphere is melted and recast into 8 identical rings. each ring being a hollow cylinder. That's all. This is the equation you should write in words. Now, if you write this under this, what is the volume of a sphere, children? What's the formula to find the volume of a sphere?
4 by 3 pi r cube, ma'am.
Very good. 4 by 3 pi r cube is equal to, now let me use R1 because there's R and R here also. For this also there is radius and radius, no? So we'll use R1 here. You have to differentiate. It's not the same, no? So you'll have to differentiate. So let's use R1 here. 4 by 3 pi, that is the radius here is R1 is equal to, what is the area of one ring? What's the area of one ring? The area of the cross section is pi r square minus r square, 8th standard. And the height, area of the cross section into height. So pi h into r square minus r square is the formula to find the volume of a hollow cylinder. Or listen carefully, cylinder. What's the formula for the, what is the formula to find the volume of a cylinder? Pi r square h, right? Here it will be pi r square minus r square into h. What is the formula to find the volume of a cylinder? Pi r square h. Here, if it's a hollow cylinder, it will be pi h. Instead of r square, it will be r square minus r square into h, which is written as pi h into r square minus r square. It is the area of the cross section. It's the area of the cross, volume is area of the cross section into height. The cross section of a hollow cylinder is a ring, whose area is pi capital R square minus small r square, area of a ring, area of cross section into height. So this is the formula to find the volume of a hollow cylinder. So volume of one hollow cylinder is pi h into capital R square minus small r square. Like this 8. So 8 into. This is the volume of one hollow cylinder into 8 will give you the volume of 8 hollow cylinders or 8 plates. This volume is equal to the volume of the sphere. Is this correct?
Yes, ma'am.
Yes, ma'am.
That's all it is. Now what will get cancelled on both the sides? Pi gets cancelled on both the sides, correct? Pi gets
Yes, ma'am.
cancelled on both the sides. Now 4 by 3 into, what is R1? What is R1?
8.
8 into 8 into 8 is equal to, I'll write it below, is equal to 8 into, what is H?
3.
3 into R square, capital R square.
20 by 3.
20 by 3, the whole square. 20 by 3, the whole square. Minus internal radius, we don't know. So see, R square. So in this equation, there is only one unknown. This is the unknown. Now you know number work, how to calculate, you know. See, there's an equation wherein you don't know R. Work this, solve this equation and find the value of R. So it all depends on how you write this first equation in words. It's enough if you can write it in words. You don't have to write the mathematical equation. Write the equation in words. Read the question. Whenever it is a question from volumes and surface areas, mostly you can have most of the questions like this. Read the question and write the condition or write the equation in words, and then convert that using the formula, convert that to a mathematical equation, substitute the values and find the value of the unknown. This is the funda. So see the fourth answer. See below the fourth answer. Start working. 5 minutes for this. Start working. If you have worked but worked in a different way, please work it like this now. You should always work it together like this. You should not find volume of the sphere first separately, then the volume of 8 rings and then equate. Don't do that. Don't do that. Because you cannot cancel pi. You would have taken the value of pi and maybe you would have divided and all that. So you should never do it separately. Don't find the volume of the sphere separately, then the volume of 8 rings, and then equate. Don't do that. Equate it like this straight away. Anybody has done it like that? Separately? Sphere separately?
No, ma'am.
No. Okay. Yeah, start working. Yeah, finish the fifth one also. Since you can see a part of the answer. Oh yeah, I'll tell you the other method also, fine. The fifth one, is this over, children? The fourth one?
Yes, ma'am.
Others?
Yes, ma'am.
Okay. Okay, so to prove that, this one is a trapezium, we have two methods. To prove that PQRS is a trapezium, we have two methods. You can do it using BPT, or you can do it using the concept of similar triangles. Sometimes it will be specified. Prove that it's a trapezium using the concept of similar triangles, or BPT. If nothing is mentioned, you can do any of the two. So using BPT, to prove that it's a trapezium using BPT. Prove that PQRS is a trapezium. So for that, what you'll have to do, draw a line. So you can draw it anywhere. You can draw it like this also. So draw, say T, PQRS, TU, or okay, something like M. Okay, so draw TM parallel to PQ. To prove that it's a trapezium, it's not a trapezium. You'll have to prove it's a trapezium. So see here, draw TM parallel to PQ. Now from that, what can you write? By construction, TM is parallel to PQ. So by BPT, immediately when you have a set of parallel lines in triangle, in which triangle? In triangle SPQ, SPQ, you have TM parallel to PQ by construction. So in triangle SPQ, you have PM, you have PM by MS is equal to QT by TS. In this triangle, in this triangle, in this triangle, in this triangle. Why did we take up this triangle? Because here only we have the construction. In this triangle, we have TM parallel to PQ by construction. So by BPT, we have PM by MS is equal to QT by TS. See, some of us will write like this, PM by MS is equal to ST by TQ. That's wrong. PM by MS is equal to QT by TS. This is by BPT. Now, what? So this answer is got by comparing proportions. This one you have because by construction these two lines are parallel. So this is one. But there's already a proportion given to you in the question. PT by TR is equal to QT by TS. This proportion is already given to you in the question. See, one proportion you get by construction. You construct, you draw a line parallel to PQ, and that set of lines is in a particular triangle, and in that triangle you use BPT and you get a proportion. There's another proportion given to you in the question itself. Now compare these two proportions. When you compare these two proportions, you get a new proportion. PM by MS is equal to what? Don't know? When you compare 1 and 2, PM by MS is equal to what?
PT by TR, ma'am.
PT by TR. PT by TR. Now look at this proportion. PM, look at this proportion. PM by MS, where is it? Okay, this one. PM by MS is equal to PT is equal to PT by TR in this triangle, in this triangle. So by converse of BPT, this is parallel to this. By converse of BPT, this line is parallel to this line. Now we have TM parallel to PQ by construction. Now TM is parallel to SR. So that means PQ is parallel to SR. And in a quadrilateral, when one pair of opposite sides are parallel, it is a trapezium. From construction, you will write one proportion. Another proportion is given to you in the question. When you compare these two proportions, you get a new proportion. PM by MS is equal to PT by TR. And this proportion applies to which triangle? This proportion applies to this triangle. Because if you see the sides, PM by MS is equal to PT by TR. So this is the triangle. This is the triangle. If this proportion is true in this triangle, that means MT is parallel to SR by converse of BPT. So TM is parallel to PQ by construction. TM is parallel to SR. Now we proved by converse of BPT. So when you compare these two, you have PQ is parallel to SR. Two lines parallel to the same line are parallel to one another. So PQ is parallel to SR, which means PQRS is the trapezium because one pair of opposite sides is parallel. Do we all understand? Ananya
Yes,
understood?
ma'am.
Hitesh? Nandini?
Yes.
Priyanka?
Yes, ma'am.
Rajarajeshwari?
Yes, ma'am.
Ram?
Yes, ma'am.
Kashmir? Tarun?
Understood, ma'am.
Now, let's try to understand using the property of similar triangles. Similar triangles. So take up this triangle, take up the triangle PTQ and this triangle TRS or ST or whatever you call it. Now in these two triangles, we have a proportion PT of the first triangle by TR of the second triangle is equal to QT of the first triangle by TS of the second triangle. Here, PT of the small triangle by TR of the big triangle is equal to QT of the small triangle by TS of the big triangle. So this proportion applies. This proportion applies to these two triangles. The sides are proportional. And these are the included angles. These are the included angles and they are equal because they are vertically opposite angles. So by SAS similarity criterion, the two triangles are similar to each other. Corresponding sides proportional, included angles equal. Included angles are vertically opposite angles. They are equal. So by SAS similarity criterion, the two triangles are similar to each other. In similar triangles, corresponding angles are equal. In similar triangles, corresponding angles are equal. Now, how do you write the correct order? How do you write the correct order? How do you name the triangles? You can use this proportion itself. I've told you. Look at the proportion. Just use this proportion. PT by TR is equal to. So this is the first small triangle, PT and QT. So write this as TQ. Okay, PT, TQ. Write this one as RT. So you get PTTQ similar to RTTS. That means PTQ similar to RTS. So angle P is equal to angle R. Angle P is equal to angle R. P of this triangle is equal to R of this triangle. Because in similar triangles, corresponding angles are equal. But angle P and angle R form a pair of alternate interior angles and they're equal. That means PR is parallel to SR. PQ is parallel to SR because one pair of alternate interior angles is equal. That means the lines PQ and SR are parallel to each other, which means PQRS is a trapezium. Yeah, start working. So you can prove that this figure is a trapezium using BPT or similar triangles. Done, children?
Yes, ma'am.
Okay. Shall we take up the next paper? Is this over? You must remember this, like, you must remember the statement that quadrilateral can be proved to be a trapezium in two ways. One using the converse of BPT, the other using similar triangles. So if it is BPT, one proportion is given to you in the question itself. The other proportion you will get by construction. You will construct a line parallel to one side. So you will get another proportion from that. Comparing these two proportions, you will get a new proportion. And that proportion will apply to some triangle. So by converse of BPT, two lines are parallel there. But you already have one pair of parallel lines by construction. So on comparing these two, you find that opposite sides are parallel and hence it's a trapezium. The other one is similar triangles. Prove that the triangles are similar, alternate angles are equal. So that means the lines are parallel. PQ is parallel to SR. So you must remember this, like exactly what I told you now. If you have a quadrilateral and you'll have to prove that it's a trapezium, you can do it in two ways. Similar triangles, converse of BPT. Yeah, start working. Do the first one. Do the first one and the second one, we'll see the answers. 1 and 2.
Ma'am?